Hello friends, welcome back to my channel Let's Learn with Jit. So today we are going to discuss about this one topic that is the continuous deployment by using the CDK. CDK is a library that is provided by the AWS and its full form is Cloud Development Kit. So it's a kind of infrastructure code that we generally write to deploy our applications, for example our Lambda functions or any other services into the AWS environment. So generally this can be done through multiple ways. One way is through using this CDK, that is the Cloud Development Kit, and another way is if you are having the Python code to be deployed, then you can if you are having some services and you want to deploy it through the Python code, then you can use the stacker and troposphere that is also provided by the AWS, and you can use those. So here we are not going to use the stacker and troposphere, we are going to use alternate of that, that is the CDK, that is the Cloud Development Kit. So here under CDK the code can be written, infrastructure code can be written in multiple languages. One language, maybe you may write your code in Java, in JavaScript, in JavaScript means TypeScript, in Python, in Golang. So these are the multiple languages where you can write your infrastructure code. And the important point to consider here, that it is the continuous deployment. So generally we heard that there is CI/CD pipeline. We generally heard about this CI/CD pipeline. So what is the CI/CD pipeline? So CI/CD pipeline is basically consisted of two important tasks. One is continuous integration and another is continuous deployment. So continuous integration, what it does, so continuous integration basically read your code from the repository. Your repository may be anything, it may be GitHub, it may be AWS code repository, it may be GitLab or SVN, anything. So this continuous integration will read your code, it will compile, it will build your code, it will perform unit testing, and it will verify that unit test cases are meeting or fulfilling the threshold value of unit test case success rate of unit test cases. If yes, it will move ahead. If no, then it will block the pipeline there and it will give some error message. And then if you are using some if you are trying to deploy some Lambda functions, then continuous integration will create a zip file of all your Lambda code along with its dependencies, along with its libraries, and then it will put those files in some artifact store. This artifact store may be S3, it may be something else, artifact store in AWS environment. It's not necessary that you need to create a zip file and you need to put it in S3. You can even go for the Docker images where it will, your CI part will create the Docker image and it will put that Docker image into the Elastic Container, Amazon Elastic Container Registry ECR in AWS, and from there your CD part, that is the continuous deployment part, will pick. So right now why I'm discussing all these things, because here I'm just trying to make it clear that I am not going to cover this part here, I'm just going to cover this part, continuous deployment part. So what it will do, continuous deployment part, here I am assuming that your continuous integration part has already pulled your code from the repository and it has created a zip file and it has put that zip file in a S3 bucket. Now this continuous deployment part, what it will do, that this continuous deployment part will pick that zip file from the S3 bucket, and then it will create all the necessary resources in AWS. For example, it will create the lambda functions, it will deploy that zip code into the as a lambda service, and it will enable the log group. It will if you have used some secret manager, then it will initiate your secret manager service. It will provide the required rules and policies to your lambda function, so that your lambda function would be able to access the secret manager. So all these things will be done by the continuous deployment, whatever the code you have written in the continuous deployment, and this kind of code is called as the infrastructure code. So these things we are going to discuss here. Okay, and for so to start it, there are some prerequisite. So first prerequisite is that whatever the programming language, I have already mentioned few programming languages by which you can create this infrastructure code. So whatever language you are going to use, that language should be configured on your machine. So here I am going to use Python, so I have configured Python 10 on my machine. And you should have a free tier AWS account. So if you are having it, it's well and good. If you are not having it, then open AWS and create your free account. And again, in your laptop or machine, wherever you are working right now, it should have the Node.Js and NPM installed, and then it should have the AWS CLI installed. So these four are the important things to be present. Now, how can you see that whether AWS CLI is available or not in your machine? So for that, it's better if you are having the Windows machine, just open CMD and just here type AWS minus minus version, and if AWS CLI is installed, then it will give you this kind of version. So that means AWS CLI is present in your system. But if it is not present in your system, then you'll have to go and you'll have to install it. So you can come on this URL of Amazon and AWS, and from this URL, if you are using Windows machine, you can download this MSI file, and then this MSI file you can install on your system. Now suppose once you are confirmed that AWS CLI is available on your system, okay, then you need to verify that Node.js and NPM are also available. If all these prerequisites are meeting, then we can move ahead with our steps. Okay, so here so yeah, before moving to the steps further, one thing I want to tell you, that in continuous deployment part, as I have mentioned, that your lambda function, here I am taking an example. I have created a very small lambda functions. This is basically my lambda function, and here I am not doing anything. I am just whenever I am triggering this lambda function, I am just printing this message that event processed successfully, and all these libraries or dependencies are just installed here only. And here I have created a zip file of this lambda function, that is the mylambda.zip. I have created this zip file, and this zip file I have put in S3 bucket. So here in this S3 bucket, that is the Jitendra lambda bucket, in this bucket I have put this zip file. Okay, so till here till up to here, this all these things will be done by your continuous integration part of your CI/CD pipeline. Okay, and here I am not going to cover the continuous integration, so I have already done it, and now and I will just cover the continuous deployment part. Okay, so I have already put here my zipped file of my lambda functions, and now I am moving ahead to describe or to work on the continuous deployment part. So here let's go through the steps. First step is AWS configure. So we understood that okay, if AWS CLI is available in our system, then we should see that whether we have configured AWS in our laptop or not. If not, how can we verify whether it is configured or not? So to verify this, we need to come to our under C drive users, our username, and then under this we need to verify that whether we are having .aws file. If we are having .aws file, go here and see if you are having the config and credentials files. If you are having, then AWS is configured on your system. If you are not having .aws file, then it is not configured and you need to configure it. So how can you configure it? So to configure it, just open cmd, and here what you need to do that just a second, cmd, okay, and here you need to just write this command, aws configure, and when you will write this command, it will ask your access key id. So that access key id you will have to generate from your aws login. You will have to log in into your aws account, and from there for your user you can generate your access key and secret key. So you will provide this access key, secret key, and then it will ask for the reason. You will provide those reasons. Generally it may be us east 1 in most of the cases, but you can verify what is your reason, and then you can add that, and then these three questions it will ask, and then you click on the enter, and then it will create your .aws file. So you can finally come here and verify that whether .aws file is created. If it is created, then it's well and good, and your this step is done. Now next step is what is the next step? Next step is that we need to, as we are going to work on CDK, AWS CDK, then so to use it, first we need to install the AWS CDK package. We need to install. So this we can install by using the npm node package manager. So for that, what you can do, simply just copy this command, and open your cmd, and just type it here and just press enter. It will take few seconds, and it will install your CDK. Once your CDK is installed, then you can verify whether it is installed or not. How can you verify? So to verify, let's go to the third step, that is the CDK version. So here we can come and we can copy that, come to cmd, paste it, and press enter. Then it will give you the CDK version. So if it is giving this information, that means CDK is installed. Okay. Next, what is next here? We need to, under the step 4, we need to create the CDK project. So to create the CDK project, let's come to some folder. So here I am coming, and here I am creating a folder. So while creating your CDK project folder, give a proper name, because with the same name it will create a stack class in your code structure. So I can write like YouTube CDK stack. I've just given this name. I'm going here, and then at this path I am opening the CMD. So CMD I have opened, and then I will come here and I will copy this command, that is the CDK init, and Python. Language is equal to Python. I am using Python, so I am giving the Python. If you are using TypeScript or Java, accordingly you can give that. So I'm just typing it here and pressing enter. So as soon as I will press enter, it will start installing, it will start creating the structure inside this folder. So if you see, it has started creating the structure, and it will take few seconds to create the structure. And if you see here, it is executing, that is creating the virtual environment. Virtual, so as we are using Python, if whoever is working with the Python, they might be knowing that in Python, whenever we are creating any application in the Python, then we create a virtual environment, and in that virtual environment we basically install all the dependencies that are required for the application. So it is here creating the virtual environment. uh, so let me pause the this video. Once it is done, then I will start it again. Yeah, so friends, here we can see that it has created the virtual environment, and it has also it was installing the dependencies, and it has installed few dependencies. If we come here under side packages, we can see that it has installed AWS CDK and all other dependencies. It has automatically installed, as it was taking some longer time, so I manually cancelled it. So here, if we see, earlier we had seen that here we had seen that we had just created this blank folder, and when we trigger that CDK init command, then it created all these files here. If your if git is configured on your system, then it will create this git folder also, and it has created all these files, and it has created this virtual environment folder also. Let's open this in VS Code. So if I'm opening it in VS Code, yep. So this is the folder structure it has created, and here the entry file is basically the cdk.json. So whenever you will trigger some command, then it will read the cdk.json, and it will first find that how to start your application, and this is the line that says how this application can be started, and this is the entry point python app.py. So if we open app.py, then here it has created this stack class. So I had mentioned that whatever the folder name you are putting with the same name, it will create the stack class. If we are using the CDK init, we can create all these things manually also, but we used CDK init. And if we here it is creating the object of this particular class, and here if you see, it is passing some environment, so we should enable it. And here it is taking the CDK default account and CDK default region. So while creating this, while configuring the server, this server AWS server, so whatever data region or account ID is present in these files, it will read from here, and it will add it here at the runtime. If we go inside this class, so this class, and basically here this is the part where we will write our code for all the infrastructure related, means whatever the services we want to initiate on the AWS side, whatever the rules, whatever the policies we want to create, all those codes we will have to write here. Okay, so and how we can do so for that, here if we come here, first we will have to come inside this virtual environment. So for that we can use python minus mvenv and dot venb. So suppose if it has not created the virtual environment, if it has not created the virtual environment, then we can create the virtual environment with this command. But it has already created the virtual environment, and the virtual environment folder is basically the .venv. So we need to activate this. So how to activate? So here what we will do, .venv backslash scripts and then activate. So this virtual environment has been activated, and suppose if our dependencies are not installed, here it has installed, but if suppose our dependencies are not installed, then we will have to install our dependencies. Those dependencies are available here in this requirement.txt. These two dependencies are there. So to install these dependencies we need to write the command like pip install -r requirements.txt, and once we will press the enter, then it will take few minutes to install this dependency, as these are installed already, so I'm not installing it again. So here till here our steps are done. Okay, so as I have mentioned that whatever the infrastructure code we need to write, those code we need to write in this class. So this class is basically one stack it is going to define. So suppose one stack means what? Means suppose we have created one lambda function. So this lambda function will require the multiple services. One lambda service it will require the log group, it will require scheduling services. So all these informations it will require. So these informations can be provided here through so all these codes we need to write it here. And a stack, as I was saying that one stack means all the services that are related with that particular lambda functions will come under one stack. So all those things we will have to write here. So suppose if there are multiple lambda function, then one stack will be one lambda function, another stack we will create for another lambda function. Suppose one service is being shared among the multiple lambda function, for example secret manager. So that secret manager we can define separately, and we can utilize in multiple lambda functions. Those things we can do. Now here what here I have already created some infrastructure code that I'm going to show. So for that I'm just closing this one, and I'm closing this also. Now let's go to here. So here I have already created this to save some time, and if we go here, the structure is very much similar. And if we come here in this our class, lambda stack class, so here as I have mentioned that I have created this lambda zip file, and this zip file I have placed in this bucket I had already shown here. So I am giving the bucket name, and this file name is basically the key name. So I am giving both the things here. And these lambda functions will be related with the log group. All the logs will be written in the log group, so I have defined a log group here. and I have given some log group ID. These IDs should be unique, so I have made it unique by giving that kind of name. And here if you see, I have defined my lambda functions. So here under lambda functions I have given what kind of Python version is required, what is the handler function. So if you see, this is my handler function, that is the lambda function dot lambda handler is my handler function. And from where the code will come, so the code will come from the bucket. From which bucket? So it will come from this bucket name, the bucket name that I have defined here. From this bucket name the code will come. And what is the key? So object key is basically this one. So from here it will get the lambda code and it will deploy this lambda code into the lambda service. And timeout period, so you might be knowing that every lambda function is having some timeout period. Maximum timeout period is 15 minutes, minimum you can give anything. And the maximum memory it can use, it I have defined it as 128 MB. You can give any amount. Okay. And function name is basically I have given some function name here, hello world lambda functions. And I have defined a scheduler role, means I'm defining a basically event based scheduler that will trigger this function, this lambda function. So that for that I have defined here some IAM role because that event breeze should have the role or policies. It should have the role and it should have the policies to invoke the lambda function. And which lambda function? So it should invoke this lambda function. So I'm providing here the ARN of my lambda function. So this is my lambda function and I am taking the ARN of this lambda function. So this is the benefit of using the infrastructure code. Here we can take the reference of the lambda function, we can take the attribute from this reference. Otherwise all these things would have been done, we would have to done manually, but here we are doing through code. So this is the benefit of using it. And here I have defined the schedule when it should trigger. So it should trigger this time. And this is basically the description of this cron scheduler or event based scheduler I have given. And I have given the time zone also. You can provide the time zone, whatever time zone you want. And what uh, resources it will trigger. So it will trigger this lambda function. Okay. And what role it is having. So this role it is having, this role we have defined here. Okay. So all these things we have defined here. So similarly one stack I have defined for one lambda function. You can define multiple stack for multiple lambda functions. Each stack you can define in the multiple class in separate classes. So it structure depends on you, how you are creating the structure. It all depends on your skill. Now once this is done, then what is the next step? Then we need to after adding our code, we have added our code, then we need to call the CDK Bootstrap. CDK Bootstrap is basically bootstrapping your AWS configure on your local, so that whatever the data you are pulling from AWS in your code, it will provide that. So let's do that. CDK Bootstrap. So it will take a few seconds. So once CDK Bootstrap is completed, then we can call one important command, that is the CDK synth. Here is that one. So we need to call this one, CDK synth. This CDK synth basically creates the CloudFormation template in JSON format, and if there is any error in your code, so it will highlight that. So let's do that. Okay. Synth, it will also take few seconds. So by that time let me pause the video. So if you see here, CDK synth is completed successfully, and it has created this CloudFormation template file, and we can verify it in our code base also. So here if you see, it has created this folder cdk.out, and under cdk.out you will find this JSON file. If you will open this JSON file, it is um, then it is having all the services or all the roles or policies that you have defined here. So it is having all those things. It is having the lambda functions, and it will be having the scheduler also. So all the information, whatever services you have created, it is present here. And after this you will have to call this command to get it deployed on your AWS environment. So for that we will have to call that. Let's clean it and call CDK deploy. It will take few seconds to few minutes. So by that time I am pausing this video. So if you see here, it has identified that what all services it needs to invoke on your AWS environment. It has given the list of those resources along with its actions and principles, and then at the end it is asking that do you wish to deploy these changes. If you are putting yes, then it will create all these services on your AWS environment, and if you are saying no, then it will discard all these things. So let's give yes and see. So if you see, it is giving the step-by-step process here. It is deploying, then it is creating the CloudFormation chain set. So it will give all these processes step by step. So here it is creating all this. I am pausing this video. Once it will be done, then I will show you. So if you see here, this deployment is completed, and it has given how much time it has taken to deploy. Now let's verify what all it has done in our AWS service, AWS environment. So first let's see whether it has created the lambda function or not. So for that let's go to the lambda. So yeah, it has created one lambda function, this one. If we come here, so it has created this lambda function, and if we come to monitor, it is taking some time. So monitor, it is giving all the details. Right now we haven't run it, it will not give any information. Let's go to the configuration. If you remember, we had given 128 MB memory. It has taken that much of memory. Timeout, we had given 30 seconds. It has taken that amount of timeout. Okay, and if we would have provided any environment variable, it would have come here. We have not provided any environment variable, so nothing is coming here. And if we test it, let's once run this application, this lambda function. So I'm just clicking on the test, it is running, and if you see the execution detail, it is not returning anything. Okay, and if you see here, it is giving some details of this information. If you remember, we are passing, if you see here, we are returning this message that event processed successfully. Same things it is returning here, that event processed successfully. If we want to see its log group, then let's go to its log group. if you remember, we had created the log group also. So within that log group it should add the logs. So this is the log group. Under this log group it has created one log group with this name, hello lambda function, and here it has entered these logs. Okay. Similarly, we can go to the event breeze to see our scheduler, whatever the scheduler we have created. Let's see whether that scheduler is created or not. Let's come to schedules. So here it has created this hello world uh, function schedule, and it has created the same cron time that we had given here. So all these things it has created, our lambda function is running. So we understood how our infrastructure code, how can we write our infrastructure code in CDK, how can we trigger it, how it will deploy our application. So this is basically the continuous deployment part, CD part of CI/CD pipeline. Now if needed, we can destroy whatever we have created. To destroy this, we need to just trigger this command cdk destroy. So if we don't want to incur any cost, then let's destroy all these things. It will again take some time, and once this cdk destroy is completed, we can again go to our AWS console, and we can verify whether all these things are removed or not. If anything is not removed, then it's better to manually remove those things. So this is all I was having today to share, and if you like this video, then please share it, and put a comment, and press the like button. And all these steps are available here on the AWS page. So here AWS page, you can find all these steps that I have discussed, so you can go through this document also. Yeah, so that's all for today.